All right. We are going to talk a little more about the law of sines in this one. Again, a quick review. Law of sines, here's the formula up here. A over sine A, B over sine B, C over sine C, right? As long as you have the side, the angle across from it, you can set that up even if it's not a right triangle. The law of sines works even when you don't have the right triangles. And so this is just a quick situation here that we're going to run through here. Just some information about a particular triangle. Got angle A is 55 degrees, side A is 17. That means these two have to be across from each other because lowercase capital are always across from each other. Same here. We don't know the angle this time, right? So what I might start with is just kind of drawing out a picture of what's happening in here. So we've got, maybe a kind of triangle here. I'm just kind of estimating. I'm not 100% sure how this whole thing is going to look. I'm just going to estimate a triangle here. I might call this side A, which means this is lowercase a across from it. Means here this side is 17, right? Here might be capital B. Maybe I'll put that on the bottom, right? Capital C, lowercase c here. This is side B. This one is 20, right? We know angle A is 55 degrees, and we want to know what this is, right? We want to know angle B. I don't know what that one is. So here what we can do, again, I've got side, angle across from it. We can use law of sines. So we might go ahead and set that up. Right? And that's what I'm going to do right away, right? I'm just going to set up law of sines, right? We can do that. Here we've got these across from each other. I've got 17 is across from the 55-degree angle. So I'm going to put that in with the sines. Those two pair together. And then here, these ones, I have to do the same thing, but I'm gonna, gotta make sure I set this up. Here's the side over sine B, right? This has to have the angle next to it, right? Sine has to have the angle in order to be used. And here we just kind of multiply this out, right? Quick cross multiply, multiply this over, divide by 17, that's equal to sine of B. It's just a little bit, right? However, here we don't get the final answer. We only get sine of B when we do this multiplying across. And again, I got to jump to my calculator. I don't have the sine of 55 necessarily memorized, but we should take 20 times sine of 55 divided by 17, right? So I'd put that all in there, and we'd come out with about 0.9637, something in there, right? So that's what the sine of B is, right? It's 0.9637, yada, 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 right? We have that all down. And then that means that we do the sine inverse to figure out what angle B is actually equal to, right? We want to figure out what that is. And so angle B, in this case here, again, I do the sine inverse of all of that stuff. So I'm just going to put in sine inverse of that answer. And we'll see there, okay, about a 74.5-degree angle, a little bit more than that. So this is a 74.52-degree angle in that case, right? That's what we would have. And now everything seems pretty well and good. We'd say this is 74.52-degree angle. If we wanted to, we could find this third one, set up law of sines again, and find this side, right? Because I can figure out that angle now. Set up law of sines again, and just like when we said we got the three angles on this side, we can do that. But there is a small problem here, right? There's one small thing, and that comes back to when we were solving trig equations, when we said, hey, when we use an inverse, sometimes there are multiple correct answers. There are multiple things that would make this true. And in fact, here there are multiple things that make this result true, because if we kind of think about it in isolation, right? We did a sine inverse here, right? This particular angle, I get it's not connected to this triangle itself, right? But just this angle B could be here. It could be the 74.52-degree angle. That is a possibility. But we could also mirror that over here, right? We could mirror the triangle over. And so yes, this could be 74.52 degrees, but just as equally, right, we could say, well, this is, let me double check on here what that would be, right? I suppose it could be 180 minus that 74.52. And this would be 105.48 degrees, right? Could it be that angle, right? I mean, maybe we could mirror over there. Sine's positive in both, right? Could it possibly be that? Or 105.48 degrees, right? So sometimes we have to check to see, does that end up working out? Which in this case, what we do to check that is I would check and say, 74.52. If I put that in here, do I have enough to make a total of 180? Which of course, I do. 74.52 plus this, there's enough to make 180 degrees. If I use 105.48 degrees and I combine that here, that means we've used a total of about 160 degrees, which means there's about 30 degrees left over in that case. So this is possible as well. And that's what's called this kind of dilemma of which one do we choose. The problem is both, right? We kind of have to choose both of them until, we would have more information. We don't have enough information in this case. So in here, we would have to say these are both the correct answer. Kind of the reason that works out, this is what's called the ambiguous case of signs. Ambiguity meaning something that we can't quite be sure of. It could be one or the other, and we don't know without more information. Just based on the given information, it's ambiguous. We don't know which one it is. We have to treat it as though it's both until we have more information to go. And sort of the reason that this works, I'm going to give you guys a little bit of a visual, and I'll also link that on Google Classroom too if you want to use this GeoGebra thing that I'm going to show you here. But so just to show you kind of why this works a little bit here, we're going to go in here and let me find this here. Okay. So if we take a look at this here, when we go into here, what we can see is I've made a little triangle in here, and we know this angle here, I set it as 30 degrees. It really could set it as anything. It doesn't really matter. And then we've got this other side as well, right? They can kind of move around. So we have our two sides and our angle, right? So in here, we can kind of move this around. If I connect it down here, it makes a triangle, right? But at times we can kind of maybe move this underneath, and here's a different angle. So it's kind of like saying, in the one we just got done with, right? This is one possibility. And that possibility might be that 74-degree angle might be right here, right? But we could also turn this, and here's our 105-degree angle that could also work in this spot, right? So sometimes that does work out, right? Sometimes it works out. Sometimes, however, it definitely does not work out, right? So for example here, if I made this thing a little bit longer, right? Let's make it even longer still. So I'm just going to kind of stretch this out. If I start here and try and swing this underneath, it's going to go way, way under. Oh boy, now I went so far I can't even see it. But we go all the way under here. Now this triangle that works out, you can see is not quite the same thing. It doesn't make that triangle because now we've destroyed this angle, right? We're using the inner angle instead of the actual smaller one. So sometimes sine gives us one answer right here because we can't make a second triangle. Or it could possibly, like before, give us two answers, right? And then sometimes, if this is way too short, there's no way for it to make a triangle at all. Notice it can't ever reach down here to make a triangle. So sometimes it could never make a triangle no matter what you do. So that can be a possibility too. So in this law of sine, sometimes you can have one possibility, sometimes you can have two answers, or sometimes no answer at all. Right? And that's why the law of sine is sometimes ambiguous. And in this case here, what we started with, we started with an angle and two sides. So a lot of times, people call that side angle, right? And back in geometry, we kind of said, this is not usable to prove something, or if you're really funny, you might switch that around a little bit. I call this the donkey method, right? The donkey method does not always work out. Sometimes it works out, sometimes it doesn't. We don't really know, right? When you're in geometry, you don't necessarily go through all this part. But now that we're in trigonometry, we're going to take a look at that. So just to give you a little bit different example of one where I'll do an example, like here we got one where we have two results. And we'll do another example where you get one result. We'll do another example where you get absolutely no result. That could never work at all. Yeah. So this was our example with two results. We're going to do another example here where we will only get one possible answer. Yeah. So that I'm going to kind of change this up just a little bit, right? And let's go here. And so I'm just going to change this one side. Again, we can change lots of things, but just to make sure here. So I'm just going to change this to like 25 this time here, right? So I'm going to change it there. So if I put this as 25, again, that updates this side here. It's 25 in that case. And then I just set this up. These two are across from each other, right? We still have this across, so 20 over sine B. And then we use our, it's a proportion, so we kind of cross multiply to figure that out. So 20 times sine 55. Oh, let me turn my calculator on here. There we go. So we take 20 sine 55 and then divided by 25. There we get, 0.65, yada, 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 yada. That's what we have here. And then to figure that out, then we can take the inverse of that stuff, right? We take the inverse here. Inverse of that stuff being 40.94 degrees, right? About 40.94 degrees. Okay, so we'd have that. Now again, we could do the same thing. And here, it's not going to work out to be something else. But in here, we could say 40.94. If we go and try and figure out, is there another possibility, right? Because here, we just look at angle B, right? Here's where about 40.94 would be over here, right? 40.94. Well, the other possibility would have to be over here, and that would be about 180 minus that, right? Just to make sure that, because I got nobody in here to check my work, I got to use a calculator to double check on that, right? It could be 139.6 as well, right? We can say, or 139.06 degrees, right? That's another possibility. But we have to check, do those possibilities work? So in here, if we take 40.94 plus 55, got a little more than 90, so we have enough to make another angle, right? We have 180 total. But if we take 139 and add it to 55, right, we get something bigger than 180 degrees, right? That'll be like 194 degrees, right? 194 degrees just between these two angles. And then we've got a third angle that we have to use. And we'd have to make it negative, which in a physical triangle we can't do. We can have negative angles, it means go backwards. But in a physical triangle, that's not going to work out. So this option, we would say, is not possible to be used. We'd say, nope, can't do that because it doesn't fit in here after we checked it. So this is the only one answer that's possible on there, right? So here now we have a situation where only one answer is possible, right? So the first one, two answers possible. This one only one because the secondary one does not work out. For the last one here, I'll show you a quick example here of an answer that doesn't work out at all. This one it goes very, very quickly. It won't take too long at all. So I'm just going to change this. We're just going to change this to a side of 15, right? Again, the angle side. And here we've got the donkey method set up. So on here, we just go through, and I'm just going to replace a little bit of this because we're just going to change this spot on the equation. So I'm just going to update it on here. So this is 15, which means, again, 15 over the angle. So these two 15s across from 55, 20 still across from B. We still go through that 20 times sine of 55 divided by 15. And so if we go with that one, right, that's right here at kind of the bottom there, see that we get 1.09. Now, those of you that are maybe doing some work on that or who were listening when we were doing the sign inverses could know at this point, we would know we're not going to get an answer, right? I know that seeing this right away, it's impossible because this is bigger than 1. And we can't do an inverse of signs when they're bigger than 1. It's impossible. But if you didn't know that, right, or you didn't notice that, this happens to me sometimes too, sometimes I'm just jumping into stuff and I just go forward. So if I try to put that in and do the sign inverse, it's going to tell me impossible. It cannot do that result, which all that means is that this side is essentially too short to get to the bottom, right? It can't do that. So here, this is impossible. There's no solution possible in that one. So sometimes when you've got this result and angle side side, when you have angle side side, there's a possibility. Sometimes you could get 1 answer, 2 answers, or maybe nothing, right? And so you kind of have to test out which situation you're in and to kind of clear up as much ambiguity as you can. Sometimes we can't, we just gotta say it's one option or the other.